Alright, this is lesson 1.6 of our Precalculus 11 class. Unit 1 is called Radicals and Rational Exponents. Lesson 6 is called Applications of Radicals. Are you ready? Alright, so if I gave you a shape like this and I said, hey, what's the perimeter? Fully simplified. First of all, I would say if you have any radicals that aren't simplified, do that first. So in this case, we have the square root of 8 is one of our side lengths. I would just cross that off and replace it with 2 root 2. So to find the perimeter after that, we want to find all the sides and add them up. So we need to find the right side and the bottom side because they're not given. Well, the right side is the left side, 3 root 2, but a little less. And we're missing root 2 of the side length on the left, and that would be the side length of the right. So 3 root 2 minus root 2 would give us the length of this side right here, 2 root 2. The bottom piece is one solid line, so it's going to be the root 2 plus the 2 root 2. So the length of the bottom is 3 root 2. And we can add all those up. So we have, root 2 plus root 2 plus 2 root 2 plus 2 root 2 plus 3 root 2 plus 3 root 2. And add up all those root 2's, we should have 12 root 2. So the perimeter, fully simplified, is 12 root 2. Alright, now if we wanted to find the area of this same shape, there's a few ways you could do it. In class, we identified 3 ways. One way is you can cut off this top nubbin and find the area of that piece, find the area of the rest, and add them together. So if we do that way, method 1, we have root 2 times root 2 is root 4, or just 2. And then the bottom piece is going to be 2 root 2 times 3 root 2. So 3 times 2 is 6, root 2 times root 2 is root 4, or just 2. So really this is 6 times 2, which is 12. So 2 plus 12, add those two areas together, we get the area of the total shape. You could also cut the line right here and find the area of a tall rectangle and a wide rectangle. You should get the same answer regardless. Another way to do it was to notice that the side and the width are kind of like a square. So if I added in this missing rectangle, I would have a complete square. So if I find the area of that complete square and then subtract the area of this rectangle, that would be method 3 that we found. We can get the same area. The answer should be 14. Alright, so we can do the same thing with a couple other examples. What's the perimeter? What's the area? Here's another example. Try working it out. Again, the steps are simplify all the radicals first, find the missing sides, and then add up all the side lengths. We found in class that this side right here was sneaky. If most people who didn't get it right their first try were because they didn't add the 3 root 5, the side length right here, into their final answer. And again, for area, there's more than one way to cut it. I just showed one way for this example. We could do the same thing with this shape. Find the area and the perimeter. Here we find the perimeter first. These hash marks mean that this is, all the side lengths are equal. And the square in the corner means this is a square angle, which we're going to take to imply that the rest of the angles are all square. So the whole thing's just a square. So we do the side length times itself. We're doing perimeter. You do side length times 4. So it's side length plus itself 4 times, and you get the area, or the perimeter for that one. The area, it would be the side length squared. So to do this binomial squared, we're going to draw our box and click like terms, and voila, there you go. Alright, the second type of application example we're going to do is you're given some ordered pairs in set notation. And so that's what this symbol is, this notation right here is. There's 4 points that make a set. And what we're going to do is we're going to plot the first point, 0, 1. And we're going to plot the second point, 2, -1. And we're going to draw a line connecting the first dot to the second dot. And then the second dot to the third dot, and the third dot to the fourth and final dot. And then to complete our shape, we're going to take the final dot and connect it back to the first dot. And so the question is, what is the perimeter of this shape that we've just drawn on a graph? We can't clearly just count the side lengths because they're diagonals. So we're going to use the good old Pythagorean Theorem, and we're going to adjust it to find the distance from 2 points. So if you recall, the distance would be the square root of one side of a triangle squared plus the other side of a triangle squared, right triangle. So we're going to make some right triangles. So right here in blue, I have a right triangle, and you can really easily see it goes up 2, right 2. And so what we have is a right triangle with legs with a length of 2, and the hypotenuse of the triangle is unknown, but it is also the length of the side of that original red shape that we're trying to find the perimeter of. And so I'm just going to take our 2's and plug them into our distance formula. Thank you, Pythagoras, or his people. And we're just going to calculate the square root of the side length squared plus the other side length squared. And we'll simplify that square root to be 2 root 2. And so the length of one side is a length of 2 root 2. Now we notice all the side lengths have the same right triangle we can make off of them. So they're all the same length. So we have 4 of these segments that we can add together. Or we could just say 4 times the side length, and that would give us our answer. Our perimeter is 8 root 2. Here's another shape we're finding the perimeter of. In this case, we have the top and the bottom are flat lines, so it's really easy just to count the spaces. 2 spaces wide up top, and it's 4 spaces wide on bottom. Now the side lengths that are diagonal, we're going to use that distance formula again to calculate what that length is, or in this case the hypotenuse of our right triangle that we made in blue. This right triangle has a side leg of 2 and another side leg of 1. So when we find the distance, we're going to write the square root of 1 squared plus 2 squared. Then we're going to simplify that and find that the length of the hypotenuse of the triangle, or the side of our trapezoid, is the square root of 5. The other identical is the same length. Sorry, the other side length is identical in length. And so that's also going to be square root of 5. So we'll have 2 plus 4 plus root 5 plus root 5. So 6 plus 2 root 5 would be our fully simplified expression for our perimeter. We could do one more example. This example has 5 points, so we have 5 side lengths to add together. 2 of the side lengths are vertical and horizontal respectively, so we could just count length of 3, width of 3. The other 3 diagonals are the same length. They create the 3 by 3 right triangle, so we can use the distance formula to find that length, and then just multiply it by 3 to get all 3 lengths accounted for. And then plus 3 for these 2 sides. So a fully simplified answer right there. There are some other examples that we didn't do in class. If you want to do those for funsies, that would be fantastic. These slides are in our SB content area. You can do these for sure. And if you do these and give me your solutions, I won't give you class credit for it, but I can find some ways to give you some kind of compensation. Not money compensation. I'm broke. But something. Hit me up. Try it out.